Mad Labs wanted to know how top footballers manage to bend the ball so much that when they kick it, the similarly overpaid goalkeeper at the other end can't get his hands to it. Unfortunately, it costs a lot to film the likes of David Beckham, so we filmed this lot from Northern Ireland, Antrim versus Armagh, in the hope that one of their players would bend the ball really, really well, and then we could ask him. We waited and waited.
Guys, go! Oh.
And after 90 minutes, nothing remotely Beckham-like had happened, much to the disappointment of both us and the crowd. So we went off to Belfast Queen's University to meet Dr. Cathy Craig, who spent years studying not only why Beckham shots bend, but why goalkeepers can't get their hands on his balls. It might not sound like the sort of academic research a great brain should be engaged in, but ball spinning is big business.
Spin is really something that is quite difficult to judge, and if you look at lots of sports nowadays, people do use spin to their competitive advantage in cricket and baseball, tennis, all these sports. And like sports manufacturing companies now specifically develop shoes that allow you to put more initial spin on the ball at contact, which essentially will mean the ball will bend more in the air.
Being able to spin a football really well means that you can earn a lot of money. So much that Cathy couldn't afford a Beckham type for her experiment, so she settled on the next best thing, an automatic ball bender. It does everything those expensive silver-clad feet can do, and more.
So spinning balls essentially create something called the Magnus effect or the Magnus force, which disrupts the airflow around the ball. So imagine that the ball is given side spin. On this hit on this side of the ball will cause it to rotate in an anti-clockwise, counterclockwise direction like this. So what happens is the ball heading in this direction, the air will flow faster around this side than this side, pushing the ball back in towards the goal.
This spinning ball creates a pressure differential, the pressure building on one side and reducing on the other. As a result, the ball bends as it heads towards the goal. All very clever, but it still doesn't explain why the bloke with the gloves can't get his hands to it. To answer that question, Cathy teamed up with the University of the Mediterranean to create a virtual bend-it machine capable of bending balls any which way she fancied. All she needed now was a goalkeeper. Sadly, the only thing he has to do is say whether he thinks the ball will go into the goal or not. So don't expect any entertaining dives into the lab wall.
Bond?
Cool.
This experiment was essentially to test the effects of spin in human behaviour. So what are the variables, optic variables, or what do the eyes pick up in terms of information when the ball has spin on it?
After a few hundred spinning balls, there was no doubt about it. Get the ball to bend like this, and the keeper just can't work out where it's going.
We set up like a virtual reality environment where we positioned the ball and then we simulated where the ball would arrive and put spin in the ball, no spin in the ball, and we asked people to make judgments about the future arrival place of the ball. Would it be a goal? Would it not be a goal? So we set up an experiment where balls had trajectories with spin and without spin. Counterclockwise spin and clockwise spin were the two spin variables, and then there was no spin condition. So we had 4 conditions where the ball arrived outside the goal and 4 where the ball arrived inside the goal.
Sometimes it was hard to see, to guess where the ball, if it was going out or not. It was a bit different than actual real life actually working, but it was very close to it, so it was useful and it was cool technology.
She's not 100% sure yet. Cathy speculates the reason might be this: a monkey. Like ours, its brain is good at working out the trajectories that recur naturally in nature, like the path of this falling nut. But unfortunately for it, and goalkeepers, the strange parabolic trajectory of a spinning football simply does not occur in nature. So its brains, and those of its distant cousins like us, are simply not designed to work out where the spinning ball is going to go. So, in the unlikely event that this County Antrim goalie is ever confronted by a really good spinning ball, the long-suffering home crowd will just have to accept that he never had a chance.